All right. Let me just share my screen. So I'm going to apologise for everyone up front because I don't reckon my stuff's as cool as the robots. But I do have stuff to talk about. I've been working with Grakn for about 12 months. Because of COVID, pretty much I've been in a research mode. So I'm not doing kind of like any products. As an engineer, I'm super interested in things like time and space. And this talk today is really about a concept I call gTime. And this was actually all prompted by the high goal, because when I started with Grakn, my first use case that I was going to work on was chatbot measurement, measuring the effectiveness of chatbots as they drive through conversation graphs. And that all comes down to time. And time became a very important thing for me. When I first spoke to Heiko, he said, "Oh, well, graphs don't handle time well in general. They don't index and store it well." So I'm like, I have to make some changes to that. So this is some of the results. So basically, time is a bit of a tricky thing. It seems real obvious, but the more you look into it, the more tricky it gets. So it's pretty much fundamental to everything. It's inherent in every phenomena, and all of the engineers out there know it's the basis of change and entropy and those types of things which affect everything. Static systems are simple, as the previous speaker just showed. Once it gets all dynamic, it starts getting complex, sometimes chaotic, and so understanding how to deal with time is pretty important. So, like, why is data modeling with time tricky? Pretty much there's a range of issues. Like, the first one is storage and indexing, and there's entire databases being derived just to be able to store and index time data fields. And that kind of depends on how I'm going to divide and aggregate it, but pretty much always with time, I'm dividing it and aggregating it. And I've got some sensible smallest increment, and I've got various aggregation methods. One of the research topics in database theory over the last 2 decades has been dealing with changing data, multiple timelines, how to deal with read and write access, and to capture all of that type of stuff. There's been a lot of work in data warehouses, slowly changing dimensions. You know, there's 8 different models of ways that you can handle data with time. It then starts pushing out to things like temporally variable schemas and data. How do I capture that? What do I do with it? The most interesting part from my perspective is mining temporal relations, because I don't believe that RDFL handles time at all well. And some feedback I've had from the market is that large RDFL graphs get quite vague on time and space when they get very large. So I was very interested to try to have a look at why that was and what could be done about it. And finally, there's time in simulations. And when I did my gTime review, so there's a kind of like a document that's going to get available. I looked at the first 6 of those because the whole simulation thing starts getting a little bit more complicated. In terms of the space that we talk about those, the first 5 take 13 pages. The mining temporal relations is 30 pages on its own. So that's quite a deep topic. So today we're just going to I'm just going to blitz through some of the stuff. The reason why I like this is it just partially shows how freaking cool Grakn modeling is compared to some of the other tools out there. So hopefully this is of interest and nobody gets too bored. But just like the key takeaway, the TLDR, is that there's some unique capabilities going to make Grakn a game changer with time. It's pretty much down to, okay, we've got the hyper relations. That turns out to be super, super useful, and we'll have a look at why that's more important than single edges. Unique attributes, that's a fundamental thing. There's no doubt that Grakn handles attributes differently to any other graph type system, and it's a particular strength, the way that they handle that. In the future, that's actually going to get better. So as a consequence of this time Research, I ended up having some discussions with various Grakn engineers, and it's clear that there's going to be a fast engine. Everyone knows that, but there's also going to be some shifts, and we're going to talk a little bit about what things we've spoken about and what things might be up in the near wind, and how that can help you with time. So one thing I'm going to kind of like discount here is like, so high frequency IO's got its own specialized requirements, particularly in kind of aggregation, debouncing, ways that I might compress the signal. And so pretty much I'm not including it in this review. The first thing is storage and indexing of time. Like, why is that so hard? Well, damn, sorry about that. Let's go through that. So the main problem is when I'm getting timestamps, if I just assume like that's a timestamp from a chatbot, I'm going to get 3 significant digits. If I try to take timestamp events from my Windows 10 event logger, I've got 9 significant digits. But at this scale, the number of unique variations per year is around 3 times 10 to the 10. That I'd have to store and index a set of unique values in terms of timestamps. And so time's tricky because it's multi-scale. Multi-scale means that I've actually, although I've only got one measurement device, I've got multiple scales of it. And that's analogous to defining something from the molecules up. Turns out to be a very tricky job handling multi-scale. So it's hard for traditional databases to store and index timestamps for fast access. And there's like 2 decades of work been done on this. There's all sorts of wide column databases and all sorts of ways of solving this. We're going to have a look at how Grakn might solve it. So the first thing that we can do, and this is really just through the power of Grakn attributes, is I can use a composite index. And by that, I mean, basically understand that time's not a number, then say, okay, it's comprised of a series of sub numbers that have got like dependencies on them. So there's some calculation that can be made between minutes and seconds and days and hours and et cetera, because this is the way that multi-scales work when you got a multi-scale number. So by having a simple composite index, I could just do that with straight integers. If I did that, what happens is that I massively reduce the possible unique values from 10 to the 10 to like 1200. And the way I do that for any single year, the way I do that is obviously the variation for each integer set or index type is much smaller than the overall variation, and I get to add those numbers up instead of multiplying them. So composite indexes look pretty straightforward. So let's just have a quick look at how might we do that. So the simplest way would be to start and just attach it to a timestamp and use integers. And that then makes it super easy to retrieve hours or days. So in this simple example here, I've defined a series of attributes. You'll notice that they're all integers. And then I define an attribute that actually holds the date time string, and that's got a year, a month, a day, an hour, a minute, and a second, and a millisecond. And the reason why that becomes interesting is it becomes insanely easy across the database to aggregate everything or select everything in a particular hour, in a particular day, in a month, a minute, second, or what have you. So that makes it very easy to index and retrieve times. Just moving pretty much onwards, because that's super basic and I don't want to bore anyone with that. If we start looking at how time might be divided and aggregated, financial systems become pretty interesting as a super basic example. And the reason is we've got timestamps, events, but they're all aggregated over periods. And those periods, pretty much for most accounting systems, a day is the main period that it's looking at. If I was doing like a 3-shift operation, perhaps I might be looking at the hour level, but in general, I'm not aggregating data at anything more than an hour or anything more precise than an hour level. But I've also got a number of custom periods, and composite indexes make it easy. So what we can do is just, again, we add up a whole load more of these composite indexes. So I had the original ones from the previous diagram, and I've just added those in essentially. So I've got all the year, month, day, hour, minute, second, millisecond, and now I've added on week, quarter, fin, half, and fin year. And what that does is it allows us to aggregate over a period. So assuming I got like an account identity and I got a transaction with a composite index and some relation joining the two, then I can sum any of those transactions over a period just straight through the match. And as an example here, I've just got, I've got an account with a key. I've got some set of transactions of type expense with a value at some finance time. And if I know that dollar fin has week 41, then I can find all of the, I can sum all of the events that happened in that week. And here's the little account event relation that relates the owner of the account to the event. So with a simple match statement, I can do all of my aggregation, and I don't need to have background processes to sum stuff together. That can just straight be a function. In the future, things get super interesting, and we'll just talk a little bit about that. So one of the things that's going to come along, so everyone knows that there's like a version 2, some of the stuff that's getting done in the background, we're going to have BODMAS. Yeah, that's a calculation thing. Any of the engineers out there like me, that's just what we want. BODMAS, super useful, allows us to set up basic calculations, plus really handy if we could have some custom mathematical functions, things like log2, sine, cos, blah, 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 exponents, and that's all common as well. Also, we kind of like need to calculate time periods. This actual GitHub issue only actually contains a few time calculations, what's the actual time period between a start and stop and various things like that. One thing it doesn't have is, what's the percentage of a time period? And that turns out to be a tricky calculation because it requires conversions and all sorts of things. In the future, I'm going to have a few advanced capabilities. Definitely, I'm flagging here. The Grakn guys can let you know the details of when that might happen, but there'll be enum types. And the reason why that's super important is what we want to do is create composite attributes. So it just turns out when you look at the world, this idea that property graphs or RDFL graphs have of the way they store data turns out to actually be completely wrong, because not everything is just a simple attribute, and in fact some attributes are composite, and that turns out to be a canonical thing, which I never understood that word until I met the Grakn people, but it turns out to be very important to the Grakn people. But by that I mean that there is no canonical definition of names. I can have a composite attribute of first name and last name, but I can have middle names. I can have pre-things that fit in front of surnames like Van, and I can have postfixes that fit after surnames. There's even people out there with only one name. So there is no set of sub-elements that add up to all names. Names are not canonical. However, times are. Times is always an hour, minute, second, millisecond component, a day, a month, and a week. So time is not a standard attribute. It is a canonical composite attribute. Each of those elements, like the minute, the second, etc. The other important point then is we need to then have some definition of units, where I've got some composite with some enum unit, and then that implies some conversion. I'd have to know that 110 seconds was 1.9 say minutes. So, but we can expect these things in the future in Grakn. I'm not telling you what's coming for Grakn. I'm just simply saying that these are things that I brought up as being important. And Grakn have confirmed that things that look extremely like these might appear in the wild relatively soon. Ultimately, what I'm looking for is functional management of time. And when you look into our time, I don't know if anyone's had the unfortunate task of doing that. What you see is 10,000 different definitions of how time should be described, and a really poor overall way of handling time. And unfortunately, I won't be able to get into the details of why our time is ambiguous, but it just turns out to be so. So let's just talk into a bit more of a, now that I've kind of like shown you the basics, yeah, we can use attributes as composite indexes. It's like one of the crazy things about Grakn, and the other thing that you've seen is that the hyper relations just allow me to set up such flexible extensions. You know, I can define a UTC thing, and then I can extend that UTC thing into a finance time, and do all sorts of things with it. So this starts getting interesting when I start looking at how I might capture read and write updates, which is like what's called a bitemporal application. In other words, I'm capturing multiple timelines of my data, and to do that, we've got to kind of like go beyond just basically changing the number as things update. Like, I don't just change the value, I've got to capture that update, or I've got to in particular, I've also got to capture things like reads. And the question of how I might do that, there's been decades of research that gone into that. I've read a lot of onerous research on that basis, particularly with RDBMS and data warehouses. And just a simple example, you know, I have this value of this thing that changes in the end of January 2019 from $19.95 to $17.95, but it wasn't updated in the database until the end of February, and so there's this gap in here, this between the red and the blue, where the data is incorrect. And really what we want to be doing is trying to capture that all out as a timeline. And how might that be done? Well, so I'm going to actually use a real example from there's a website that goes through a lot of the concerns in data modeling with time. And funnily enough, they use property graphs to try and show a better way. And I'm going to show you that's a freaking nightmare. But essentially, if I want to model read-write access in RDBMS or data warehouse, as I've previously highlighted, there's like 7 different ways of doing it, and it all becomes a nightmare unless you use the final one, which is 6 normal forms. So if anyone who doesn't really know the normal forms, well, I don't either, but that basically means fully atomic, like a fact-orientated model. So there's no tables, everything's just a piece of data linked by other links. So the guy who I'm quoting here in this diversity study, he said, oh, well, that's all really hard and there's got to be a better way, and I'm going to use a property graph model. Now, that turns out to be absolutely super clumsy. Neo4j would be a freaking nightmare on this, because every one of these properties, any of those properties that I want to make temporal, have to suddenly become an entity. And this is one of my gripes about Neo4j. Hey, not everything's an entity, right? And in fact, there's a lot fewer entities than you suspect. I mean, just looking at this diagram, here's the question I'd ask, although it's kind of like rhetorical because I can't really hear anyone. How many entities are in this diagram? Well, Neo4j is going to see 5. I see 1 as the employee. The rest is all just data attributes. But if I was doing this in Neo4j, all of these have to be entities. And then getting these properties so that I could store the data, I'd have to make them entities too. Grakn makes this super easy, trivial. And the way we're going to do that, I'm just going to show you something that might be a little bit different. I don't tend to use entities very much, so maybe that's going to be a bit contentious. In my diagram, I only see one entity, and that's the employee. And the rest are just relations. They're not even attributes. And the first thing I'm going to do is I'm going to convert any of these temporal variables into relations. I'm going to do that this way. And I just set up some simple, I got a temporal list. You'll see it's got an index, it's not a key. So I could have similar values. It's got an op type, that's basically read or write. It tells you whether it's the current record, it relates the owner, like the employee, it relates the item, any of this data stored in here, and the user ID is the person who updated it and gives you a timestamp. And then what I'm going to do, so that's my basic structure to hold all temporal data in Grakn. That's all I need, and I can smash out every other database under the sun just using that simple, trivial little structure here. Now, what's important is I then create variants of that for each one. So I've got a certain type of list. I can a list to handle addresses, dependents, etc., etc. And then what I'm going to do is set up the owner. I'm sure everyone's seen this type of stuff before. You know, I got a series of attributes, and then the entity has those attributes. And you'll notice down the bottom here, it plays the role of owner. So the entity is the thing that owns everything. And then I'm going to set up the temporal attributes. I haven't done all of them, just for example. So it's street, city, postcode, state. So in addresses, let's just, and I'm going to focus on this example. I've got 4 items of information that need to be saved along with the time and date that they were accessed. In terms of my time definition, you'll notice that I'm still using the finance time. So not only has it got, it's got a composite index in there, not only has it got years, months, days, hours, minutes, seconds, and milliseconds, but it's also got quarters and financial quarters and all sorts of stuff. And that time piece plays is the created. So then inserting records becomes super simple. I got my temporal list, and you can see I can, I assume my employee's already written in there. So okay, let's insert. And the reason why it's kind of like interesting here is I don't know if anybody knows, but Grakn, or how many people know, but Grakn has what's called unconstrained cardinality, and you'll notice here that one of the things I got like a time. This is actually the address that I used to live at in Bondi Beach. Street, city, postcode, and state. So I've got 4 items and a time, and you'll notice that I can write all 4 items of those. So item here has a many to one capability it's created there. So you can see that even though I've actually only got 1 item in this context, I've got 4 pieces, and I'll just store all those at the same address on the same created time. And you'll notice that actually I'm writing this as currently true. Now, there were going to be, so part of what I kind of like wanted to do is show some rules and etc. that that could be used. But the reason I haven't really shown those is because I didn't want to get too heavily into describing my own functional syntax. Let's wait till the calculations actually come out in Grakn before I show you how I might write the calculations in the G4 file. But essentially, I guess the key point here, I've really just only gone through a few things, but I just wanted to say that traditionally, graphs are really poor at indexing timestamps, and that's really got to do with the pure number of unique values. And Grakn's the game changer in time, because pretty much now I could do very effective composite indexes super simply, just on my own, don't need any special help for that one. Hyperrelations make it real easy to create sophisticated temporal lists. I don't know if anyone here is familiar with what's called anchor modeling or data vault modeling, but these are super sophisticated, decade-old frameworks which are used to store temporal lists. And you'll find when you look into those that my simple idea of the temporal list actually outperforms all of those pretty substantially. In the future, what we're going to see is much faster storage and retrieval in version 2. Everyone knows that, but more importantly for time, some functional language enhancements, BODMAS, brackets, order, division, multiplication, addition and subtraction, functions, enums, canonical, and most importantly canonical composite attributes with units and conversions. That's a freaking game changer there for sure, because no database on the planet has ever dealt with physical engineering units that engineers have to deal with every day. And for any of the engineers out there, actually having that built into the database is just insanity. And obviously we can't wait until that comes. Anyway, I didn't want to bore anyone. I hope I haven't bored anyone. So that was just a couple of quick descriptions on time. I could extend that if anyone wants to talk about it. I wasn't really sure if anyone was interested in time. If people want to extend or have questions, I'm happy to do so.
Bravo, Brett. That was excellent.
Was that too quick?
Say that again.
Was that too quick? I'm sorry if that was.
No, that was perfect. That was perfect. I think you'll find in Discord there was a lot of chatter. There was a lot of great response to this work. So kudos.
Well, if I've got a few minutes, I'd just like to talk about mining temporal relations. I've got a few images. I'll chuck.
If you wouldn't mind, do continue it in the Orbit channel on Discord as because we're about to make the switch to our final presentation of today. Does that work? And before you jump off,
anyone who wants to contact me can email me here or contact me through Daniel. It turns out, I've done a lot of work in relating time and understanding how to mine coincidence and the causal dependence of sequences. So that's something I've done a lot of work on. So happy to share that stuff with people. I will be open sourcing this stuff. Daniel's asked me to, but we're going to restrict some of it because I pretty much wrote a functional Grakn language in there, and we kind of need to wait until that's a little bit more valid. But you can hit up Daniel for any of that work. I hope that was interesting. Thanks for your time, everybody. Hit me up if you want to chat.